Yes.
Good morning, esteemed guests and colleagues. So, on this World Water Day 2025, dedicated to the theme of glacier preservation, we are reminded to the critical role of glaciers play
Not
in this.
audible to me.
Please speak.
Can you hear me, sir?
Yes, yes, yes.
So, good morning, esteemed guests and dear colleagues. On this World Water Day 2025, dedicated to the theme of glacier preservation, we are reminded to the critical role of glaciers play in sustaining our planet's freshwater resources. So, it's our privilege to have with us today our distinguished speaker, Professor Dr. Elango Lakshmanan, Professor Emeritus, IIT Madras, whose expertise in hydrology will enrich our understanding of sustainable water resource management. We are honored to welcome our Director, Professor N.B. Chalapati Rao, sir, whose leadership continues to inspire our commitment to environmental stewardship. A warm welcome to our senior scientists, colleagues whose relentless dedication drives our collective pursuit to knowledge and sustainability. As glaciers melt at unprecedented rates due to the climate change, this preservation becomes essential for maintaining the water security, ecological balance, and human livelihoods. Let us use this occasion to reaffirm our commitment to protecting our planet's precious water resources. Together, we can make a difference in addressing these challenges posed by the climate change and ensuring a sustainable future for all. Once again, I'll welcome to all of you in this auspicious World Water Day celebration. Now I invite our director, Professor N.B. Chalapati Rao, sir, to give the inaugural address.
Good morning, Professor Elango. Can you see me?
Good morning.
A very good morning to all of you, and very warm welcome to this International Water Day celebration. You all know that 8th of this month happens to be the World Water Day, but we are celebrating it today because, yes, those who are there, they can come in. No? Right. So I welcome my colleagues who are there. I request our colleagues, no, the senior faculty members, to sit here, no? Unless they are comfortable there, okay? To dear research scholars, students, all invitees. So we all know that water is a very, very important essential commodity along with soil, because without water there is no life, as simple as that. And there is every reason to celebrate the World Water Day in that given context. So water actually is a very unique compound. Its structure itself is very unique. It has a dipole nature. It is a universal solvent. And its characters, water, without water, no life can sustain. Actually, I should tell you, from geological point of view, if there is no water, along with other volatiles like carbon dioxide, there would not have been plate tectonics at all. So the water played a very important role in the survival of, or even the differentiation of the planet Earth itself. Now, water also played a very important role in the ancient civilizations and their migrations. Some of the great civilizations all thrived on the banks of the rivers. You take Indus Valley civilization, you take Mayan civilization, you take Chinese civilization, Egyptian civilization. They were all on banks of rivers. As these rivers got dried up or they shifted, then the civilizations also shifted and the migrations happened. So water's role is unparalleled in shaping our destiny itself. Now another important aspect is how water on earth has come into existence. That itself is $1 million question. When water appeared on the earth, people, we don't know the answer, but at least we know, based on geological records, the water records are available right from 3000 early Archean time, because we get precipitates like cherts, evaporates, all these would not have been there if water was not there. So water has attracted scientists, even everyone, general public as well. And origin of water, as I said, is very enigmatic. We don't know. Actually, people have ascribed water origin in mythology to the gods. Like Bhagirath has invoked Lord Shiva to have Ganga onto the earth. If you combine science and mythology, I look at mythology from scientific point of view. Ganga descended onto our planet Earth because from mythological aspects. In other words, people have always ascribed to the skies to source of your water. The latest scientific theories say that perhaps water originated from meteorites. They have some hydrocarbons, and from there they were carried on to planet Earth. So today we are facing lot of challenges. That's why World Water Day is celebrated. Water contamination is rampant. Water resources, surface and groundwater resources are getting depleted. And seawater influx and contaminating groundwater aquifers is happening. So that's why we are living in times water is being sold, which was unthinkable 15, 20 years ago. We are buying water, pure water, uncontaminated water. So the celebration of our World Water Day assumes extreme importance. And NCESS from the inception, Professor Elango, you would be knowing, were involved in always in water related studies. Our biogeochemistry group or environmental hydrology group, very actively involved in monitoring the water resources, not only in Kerala but in other parts, geothermal springs, their quality, and SDG, your submarine groundwater discharge. This concept itself has emerged from our NCESS. So our scientists have always been involved in these activities. So without taking much time, I thought we always celebrate such events in much grandeur, and we are very privileged to have Professor Elango, who would be introduced very formally by some of my colleagues. But I should say he is a very distinguished, well-known hydrologist and groundwater modeler who quantitatively, he is known for his quantitative studies. Empirical studies so many people are carrying out, but the uniqueness of this research, I understand since many years, is a quantitative approach, and he is sort of person in many of the committees and also policy makers. So I am very glad that he is there. Of course, we miss you that you are not there physically, but I am sure it doesn't matter, because we are living in the virtual world where technology is helping us to great extent. So once again, I welcome each of you and Professor Elango, and I look forward to the further proceedings of this program. Thank you.
Thank you so much.
Thank you so much, sir,
You
for
have given a
enlightening
nice
lecture.
introduction already.
Thank you so much,
You
sir.
can take
Now I
Maybe 1
formally
minute.
invite Dr. K. Silas, Chairman ESF, to formally introduce our speaker.
2 minutes, Vikas.
Yeah, sir. Good morning, all. Actually, it's a privilege to introduce Professor Elango. He was my guru. He taught me geology when I was doing a master's in Center for Water Sources. Of course, he also did his Master of Engineering in Hydrology and Water Source from Center for Water Resources, maybe two decades before me. So his background is applied geology. He did his BSc and MSc in applied geology from Anna University. And again, he did an ME in Hydrology and Water Source from Center for Water Sources in Anna University, and PhD in Groundwater Hydrology from Anna University. So since 1986, he's serving Anna University in various capacities, first as a lecturer, then senior lecturer, assistant professor, until he retired as a professor in May 2023. So he have more than 40 years of experience in hydrology and groundwater hydrology, and he have several national and international projects. He is well known for his concepts on managed groundwater aquifers, mainly in the Chennai region. And he have organized several national and international workshops. He also has a postdoc from University of Birmingham. I will quickly finish it, sir. So he have, I'll cut short. He have several projects carried out, 26 national projects to the tune of 18 crores, and there are 33 students who have completed PhD under him, and there are 8 postdoctoral fellows working with him. He's editor of several journals, and he has several publications and more than 11,000 citations as of now. Currently, he is a full-time visiting faculty in hydrology and hydraulics and water source engineering division in Department of Civil Engineering, IIT Madras. And while continuing his research work, he is also a co-investigator of Indo-Dutch research project on resilient hydro twin, participatory integrated digital twin for adaptive urban resilience to water extremities. With this brief introduction, I welcome Professor Elango once again to ENCESS and kindly request you to deliver the distinguished talk. Thank you.
Thank you so much for the nice introduction, Srilash. My dear friend, Professor Chalapati Rao, Director in ESSO-NCESS. It is really unfortunate. When I see the auditorium, I have been there many times. I really miss to be among you all today. I hope you will give me one more opportunity later on during the year. Especially, thank you. Especially, I cherish the days when we formulated the SGD project, which ENCESS led maybe several years ago. Though a lot has been told about this theme of this year's World Water Day, which is revolving around glaciers, I would like to say I have not done anything on glaciers, but I would like to talk more on groundwater toward the end. Little bit of for a study, we had a look into the situation in Himalayas. I'll show one slide toward the end. So I would like to focus on what are all the various approaches for sustainable groundwater management. The entire presentation is based on our own studies. We all are aware that the temperature is rising. If you look at this diagram brought out by IPCC, even the observed rise in temperature until this time, right? You can see the temperature is rising, and which is very evident from the observations which we are making. Beyond that, the projected rise in temperature under different scenarios are given here. So this is the path in which we are actually in. But if you are in midway, even then the temperature is going to rise by 2 degrees by the end of this century. If you follow the best path, which is highly unlikely, even then the temperature is going to rise by 1.5 degrees by the end of this century. So atmospheric temperature is continuously increasing, which we are all aware. What is the situation in India? So in India too, we are observing, so this paper highlights the observed rise in the atmospheric temperature, right? Mean summer temperature has been plotted here. You can see that trend line, the temperature is rising. These are all observations, right? Many times we question the way in which we project. So hence I'm showing you the observed value first. And this is how the projections indicate the temperature is going to rise in India to more or less at the same rate as the temperature is going to rise in the world, right? Mean temperature in the world, right? So what we had seen on the previous page, in the same way here too, right? Even the best part indicates 1.5 degree rise in temperature, whereas in India, some models predict that temperature can go up to 5 degrees by the end of the century, right? And another interesting feature which I would like to highlight, since this year is on glaciers, the rise in temperature, as you can see in the scale on the right hand side, right, as per their findings, is going to be much higher. This is what is very painful. It is going to be much higher in Himalayan region, right, compared to the southern India or rest of India. So what is going to be its effect? Means we are going to lose our glaciers. The glaciers are going to be converted into water. Eventually it will reach the sea, contributing to the sea level rise. Already sea level is rising due to melting of ice mass both in the poles. Adding to this, the Himalayas is considered as a third pole of the world. So we are going to lose this water too. Right? What are all the impacts on groundwater? Right? Since I work on groundwater, I would like to talk more about groundwater. So what are all the issues? So first is, it is going to lead to depletion. How it can lead to depletion? Whether there is going to be rise in rainfall or fall in rainfall, right? When the rainfall is increasing in some parts of the world or in our country, most of it is going to go as a runoff because heavy downpour which are witnessed is, right, including Kerala, in several parts of the world, in several cities in India, a huge downpour leads to flash floods. So most of the water runs down. So even the increase in rainfall is not going to be very, very helpful. It is going to run into the sea. If there is going to be fall in some regions, the rainfall which we are receiving is going to get reduced. Over there to the segregation, that means the part that is going to get into the earth is going to be reduced. Another reason for reduction or depletion in groundwater resources is this. That means, as we had just now seen, the atmospheric temperature is rising. So the quantum of water that is going to evaporate from the surface of the earth is going to increase day by day. Right? But the water which we lose due to evaporation today, right, is considerably lesser than the water which we are going to lose after 10 years. This will also eventually lead to reduction in recharge, because when we lose large amount of water as evaporation or transpiration during the subsequent rainfall time or subsequent monsoon time, the rainfall has to first of all satisfy the deficit in the soil moisture. Only then it can infiltrate into the groundwater zone. So this is also going to lead to changes in the way in which recharge is taking place today. Adding to this problem, urbanization. Large cities leading to rise in temperature locally around the city, right? If you can, there are many researchers, including we did a study in Chennai. The temperature in Chennai city is at least 2 degrees above the surroundings, right? Which many of us would have witnessed. Maybe when we come from a suburb into the city, we would have felt the increase in temperature. So this also adds up to the problem of climate change, leading to thunderstorms. Right? And urbanization and changes in land use and land cover lead to more area which was previously open surface area has been paved or converted into built up. That is also going to reduce the recharge, right? Because the soil has been completely covered. Another dimension of climate change is water quality, right? Including both surface as well as groundwater quality is going to be affected. It is very clear surface water quality will be affected due to increased evaporation. When the more water is lost due to evaporation, the salinity of surface water is going to increase. The same water will go as a recharge. Suppose if this is a river or pond, more evaporation, only H2O goes. This saline enriched water is going to get recharged. So this will deteriorate the groundwater quality. Adding to this problem, the way in which, as Professor Chalapati Rao mentioned, the way in which rock and water are interacting today will also get changed due to rise in the atmospheric temperature, right? Which can also be influencing the groundwater resources, due to which the water quality is also going to be affected, right? In fact, 2 years ago, we conducted a special session at the International Association of Hydrological Sciences on impacts of climate change on water quality. Another impact is the seawater intrusion. So today, this is the seawater has intruded up to this, but every day sea level is rising, due to which the area that is going to be occupied by seawater intrusion is also going to increase. What are the repercussions? There are many such other impacts, right? All of this will also lead to the way in which we are pumping today. We may also slowly change. That means, as the surface water resources are limited, or they are going to be very much contaminated, we may depend much more on groundwater, or within a year, the way in which we are pumping groundwater will also get changed. For example, right, today we may have a year with a perfect monsoon. So during monsoon time, we may not pump groundwater. Due to climate change or thunderstorms, the way in which we are receiving, the time at which we are receiving the rainfall may also change. So during that time, we may also depend on groundwater. So these are all some of the important things which I thought of, that means the climate change impacts on groundwater. Right? If you look at, we said, depletion of groundwater resources. So globally, many researchers have worked on understanding the groundwater depletion. So this paper was particularly caught my attention, because rather than depending on grace, they had made use of several observation wells, and looked into over 1,700 aquifer systems in the world distributed at different countries. So if you look at India, so in India, what they have done is they have compared the past and the present, right? That means they compared what is the relation between the groundwater level between 1980 to 2000 and after 2000, right? So using that, they had indicated the regions where the water table has gone down in the past 40 years are indicated by these colors, right? There are some regions where water table has become shallower also, right? Both positive and negative side, but the region where the groundwater has gone deeper is much more. If you look at India, especially our southern India, in several parts of India, groundwater table has gone down. So what we had seen on the previous slide, right, I'm going to give you some examples in the following slide. So here is the first example on how globally groundwater levels are falling down. And what is the impact of climate on groundwater? So here too, what they have done, right, how the different aquifer systems are behaving to the climate change, right? That means 20 years before 2000, 20 years after 2000, right? What is the change in the groundwater level, right? With respect to these 20 years, before 2000 and after 2000. So what we had seen on the previous page, right? This is what we had seen on the previous page. So they have come out with how different percentage of the out of 1,670 aquifers, how many aquifers are affected very much by the depletion in groundwater resources. So as you can see in the table, right, more than so many number of aquifers are affected due to climate change impacts. We cannot also completely attribute this to climate change, also due to expansion, increase in population, increase in the need for food production. So to cater to agricultural purpose, we may be also over withdrawing groundwater. And if you look at the case of India, what is interesting is most of the region in the world that are affected are along the equatorial region, right? So what does it mean? That means climate play an important role. Means the equatorial region, we are very much dependent on kind of monsoonal rainfall and the quantum of water which we get, right? And also quantum of water which we get may be on par with the rest of the world, but the seasonal and temporal variation in the way in which rainfall occurs in the equatorial region makes equatorial region much more vulnerable for climate change. Then here is a study which we carried out, right? Extreme events, rainfall events also deteriorates the groundwater quality, especially because of the reason where our surface water bodies are very much contaminated, right? And because of huge pollutant load due to domestic and as well as municipal solid waste, the surface water resources are heavily contaminated. So even the extreme flood events are unable to improve the situation, which we could witness in Chennai, right? The blue color is a river which is flowing through the Chennai city, which is most of the time very much contaminated. During one of the extreme rainfall event in 2015, right, the river swelled and most of the red part is completely affected or inundated due to the floods, right? What had happened is, right, though huge amount of rainfall diluted the total dissolved solids in the river water, it could not dilute the microbial load considerably. Hope I am clear, right? The chemically water quality has substantially improved. Microbial wise also water quality has improved, but it is not sufficient enough, right? What had happened is the quantum of microbes that were present in the flood inundated area has infiltrated into the ground and contaminated the groundwater in terms of microbial population too, right? So chemically water quality has improved, but microbially the water content has what groundwater quality has deteriorated. So here you can see, right, what we have looked into. At these are all the location numbers, right? Here you can see a vector diagram. Right? What we did is we collected groundwater samples in the wells which are located in the flood inundated area. This is the count of microbes, right? Yeah, this is the total bacterial count. So it was so much, but when we collected samples little bit later or little bit away at the same location. For example, if you collect groundwater sample from a flood inundated area, total bacterial count is much higher. When you take groundwater sample little bit away from the flood inundated area, microbial content is much lower. So this indicates extreme rainfall events over such regions which are having contaminated surface water bodies actually deteriorates the groundwater quality, and also health of the people got affected. So here we did a study on what will be the health impacts due to different microbes that are present in the groundwater. How people get affected due to different diseases immediately after the extreme events. And we also did a study on what are all the antibiotics that will help us to overcome the problem faced by the human health. So here is an example that groundwater quality is also affected by extreme events. And we were discussing about the rise in atmospheric temperature. When the atmospheric temperature increases, it will also affect the subsurface, right? Though the temperature as we go down the surface is expected to increase, when the atmospheric temperature rises, the soil zone temperature also will rise. So this is what these people have looked into, how with respect to depth, right? This is the surface of the earth, and with respect to depth, how the temperature will slowly go down, right? So they have carried out a study at different locations. So everywhere, as expected, the temperature is going to fall with respect to depth. But what is interesting is when you compare the variation in temperature between 2000 to 2020, from 2000 to the projected value, right? That is before 2000 and after 2000. So here the temperature is much higher, sorry, not much higher, about 1 degree higher than the deeper zone, whereas in 2100, the surface temperature will be at least 2 or 3 degrees higher than the temperature at the bottom. Not only that, the temperature beneath the surface, even at 60 meters, is going to be considerably higher than what is the situation currently. Right? It is very obvious. That means when the temperature of the atmosphere increases, it will have an impact on the subsurface too. In fact, how do we define, the hydrogeologists or groundwater hydrologists define soil zone as the zone until which there is an impact of changes in the atmosphere. So, which is so obvious. When the atmospheric temperature rises, the subsurface temperature will also increase. When the subsurface temperature increase, the groundwater also becoming warmer. So what will be the implications? As we discussed previously, so the warming of groundwater will affect the chemistry of groundwater as well as the microbial content, right? Because of warming, some chemical reactions can be happening much more rapidly. It is something like when you add salt in water, it takes some time. When you heat the water, salt quickly dissolves. So same thing is expected to happen beneath the surface. And these changes will also affect the ecosystem, right? Obviously, it will affect the ecosystem. Any microbial activity or changes in water quality will affect the ecosystem. So these are all some of the broad impacts of climate change. That means beneath the surface, groundwater temperature also is increasing. And the next dimension is seawater intrusion. So we discussed, right, that this is how normally seawater will be present on the land side. This is the land and this is the sea side. So because the seawater is slightly denser, they are present at the bottom. But as the sea level rises, I already indicated, as the sea level rises, the extent of intrusion will also increase toward the land side. So as the sea level rises due to global warming, the extent of seawater intrusion will increase. Another reason for rise in sea level came out by a group of researchers. They indicated the several parts of the world, right, especially the world along the equator, countries like USA, India, China, we are extracting large amount of groundwater. So whatever water which we have pumped, for example, if you take India, approximate estimate says around 225 kilometer cube of groundwater we are extracting per annum. So where this water will finally end up? The water which we pump actually go back to the sea, right? Nearly at least 80%. The consumptive use of water is very, very less, right? The water which is completely consumed is going to be only 10-20%. So the rest of the water has to eventually end up into the ocean. So the overuse of groundwater also leads to rise in sea level. So these are all some of the issues, right? We had a study thanks to NCESS, right? As a part of our SGD project, we did a pan-India study to understand how mainly to identify sites which are vulnerable for seawater intrusion and sites which are vulnerable for submarine groundwater discharge, right? SGD or seawater intrusion, right? So for which we collected the groundwater levels from all the wells located along the coastal region. So we could compare, we took for this study, we took the esteemed summer time between 7 and 17. So here you can see the area occupied by this color, that is red and orange color, has marginally increased within 10 years. So approximately over 400 square kilometer area, the area of over 400 square kilometer area, groundwater table has gone down below zero, right? Actually the red color, right? So the region occupied by red color has increased by nearly 400 square kilometers. What does it indicate? We are losing our fresh groundwater for the intrusion of seawater. But at the same time, there are locations where submarine groundwater discharge is also happening, but the sites at which SGD is happening on the east coast is considerably less than the west coast, right? The major reason for this is the east coast is relatively flat, due to which there is a possibility of seawater intrusion due to over withdrawal, whereas the west coast is considerably safer because of the high, or how can I say? So maybe due to a vast difference in the elevation of ground surface and the sea on the west coast. So this actually facilitates submarine groundwater discharge. The vice versa is not happening on that is seawater intrusion is not happening on the west coast. Right. So what are all the ways, right? So I would like to conclude by bringing out some of the successful stories. So one way of mitigating this issue, which India is successfully managing according to me, is to go for improved aquifer recharge. So that means managed aquifer recharge is nothing but purposeful recharge of water, right? So I used to call this as a kind of a nature-based solution, right? As we intentionally replenish groundwater through the natural process like infiltration, right? So that means we can do that by recharge wells or percolation ponds, which are called as recharge basins, or also by facilitating recharge by withdrawal of groundwater. That means when you withdraw groundwater, you facilitate more recharge. With this process we call it as river management. So different methods can be adopted. So these are known as recharge basins, where several contour channels, contour bunds are constructed to convert a relatively sloping area into a kind of a terrace cultivation. We used to do similarly. Here we are harvesting water, and or we can also go for recharge wells, as you see here, right? Or percolation ponds. So I would like to quickly run through some of the case studies in which we had used aquifer recharge to improve the groundwater storage as well as the quality. Right. So these are all the case studies I'll quickly run through. So with regard to high fluoride in groundwater, right, most of the states in India are affected by high fluoride groundwater, and people are knowingly or unknowingly they are using the water, right? Though this is well known to us, especially at Nalgonda district, we carried out a study about 10 years ago, a specific technique for cleaning the water, which is also popularly known as Nalgonda defluoridization method. People hardly use that, right? So we thought of, can recharge will benefit such sites which are contaminated by fluoride? Due to fluoride in groundwater is due to geogenic reasons, right? So here we thought of bringing in recharge to reduce the fluoride concentration. So there was a site in a fluoride affected area where an existing dug well was chosen for our study. So in that, adjacent to a dug well, we identify an area which is normally used to store the food grains, right? Usually agricultural area will have a small piece of land reserved for storage of agricultural produce. Such site was chosen, and we modified the contours of that site so that the water that falls here can be diverted into a small chamber. This chamber is also cost effective, about 1.5 meters depth and 1 meter dia. Here I think somewhere maybe 1.5 meters and 1 meter in diameter. So what the purpose is to collect the rainwater and allow it to pass through this small chamber, which we divided into 3 compartments with the coarse sand and the medium sand. And here, though we plan to fill it up with fine sand, we didn't do. We just left it empty. It is not very clear now. So coarse sand, fine sand, medium sand, and this was left empty. So the water gets filtered through the kind of a natural filtering medium. The water is allowed to fall into a adjacent dug well. So what is the benefit? So we could get tremendous benefit, right? So this is the location at which this intervention was made. Due to the recharge, you can see groundwater head is forming like a mound with a higher level here and lower level in all the sites, right? So for this purpose, we identified another set of wells, which you can see in blue color, to understand what is the variation locally. Apart from that, we had monitoring wells all over the site because they were very much away from this site. In order to understand the impact of recharge from here, we chose within 400-500 meters wells around that. Using that, we plotted this groundwater table map. Then, what is the impact on temporal basis? So this, at the bottom, you can see the rainfall, and above that is the groundwater level, and over and above that is the variation in electrical conductivity. Here is the fluoride concentration in groundwater. So the dotted line indicates the date on which we made the intervention. So sometime during 2013 or 2014, we completed the construction. This intervention was made. So here you can see immediately after that, for the rainfall which is much less than this, the response groundwater level has considerably increased because we are directly diverting the rainfall into the open well. What is the benefit of that? This has reduced the electrical conductivity. The average was somewhere here, so it has come down. So there is a marginal benefit in the electrical conductivity. Similarly, fluoride concentration, which was about 3.5, has come down to about 1.5. So this is how the intervention of a dug well led to reduction in the fluoride concentration. We had submitted this as kind of a technical report to Jal Shakti Ministry at that time. There was a competition. We participated in that. We have won the first prize. I don't know the year, maybe 17, 18. Subsequently, our Deepankar Saha was the member of the CGWB at that time. So they came out with a policy intervention of promoting dug well recharge system, right? Though we had said to identify a suitable site, a long-term hydrogeochemical study is necessary, but they ignored that. They went ahead for a dug well recharge system. There was a new scheme that has been dispensed with now. Farmers were directly paid money if they adapt this ductile recharge system. Right, and we continued monitoring at the same site for further period of up to 2017. So here you can see the concentration of fluoride is, we identified a local person, requested him to monitor on a weekly basis, right, using a pen type fluoride meter. So we were happy to find that the water quality is continuously remaining below the permissible limit. So that is how managed aquifer recharge improved the fluoride affected area, improved the groundwater quality in a fluoride affected area. Then the next is a percolation ponds. So here is a site where groundwater is very saline due to geological reasons, because in the past the region was under the sea. This is just north of the city of Chennai, just south of the Sriharikota, from where we launch our satellites, right? This marine sediments is leading to saline groundwater. The salinity of groundwater is almost as that of seawater. There are several hamlets there. People are living at that time. Now they are supplied with the desalinated water. No longer they use this. But I would like to say this as wherein we had went ahead to bring in a kind of a freshwater lens so that we will be able to tap at a slower rate for meeting the requirements of a small hamlet around this site, for which we went ahead with a percolation pond at this site. And we did a long-term study, right, nearly for 4 years with automatic water level recorder and several piezometers made. 4 piezometers we did to different depths. We had put automatic water level recorders, and since we had an automatic weather station here, so we could on a daily basis or on an hourly basis, we could compare the rainfall as well as the response of rainfall in improving the groundwater level in these piezometers. Right? So then I found out only the percolation pond at this site may not be sufficient enough because of the geological conditions here. Though percolation pond will work very nicely in a sandy area, at this site we had a kind of sandy silt or sometimes silty sand, right? So especially in the top 2 meters. To overcome the slow recharge, then in the subsequent year we went ahead with a recharge well. So you can see the construction going on. So with a recharge well was made and the top was perforated, right? As you can see here, we perforated. That means we did like an inverted. So usually the screen part will be at the bottom of the well. So here we have perforated, and also I think the entire well we provided with the perforations. So the water which get accumulated in the percolation pond, it will also go as a recharge through the sandy formation, but it will also bypass the low permeable layer directly. It will also go as a recharge. This has considerably benefited to improve the groundwater condition. Here you can see, so this was our first year measurement, right? What we did is, since we measured on a daily basis, so we monitor the level of water in the pond as well as the level of water in the piezometers, right? So, sorry, it was on this side, right? So if the groundwater is up to this, we will be measuring the level using this piezometer. If when it comes here, any piezometer can be used to measure the water level, right? So based on the daily measurement of pond water level and the response of groundwater level, we could estimate how much is the recharge, and also we know the pan evaporation. That means we have the evaporation rate and the rate at which the pond water level is falling. So the rest has to go as a recharge. So the volume that was lost has to be either due to evaporation or due to recharge. So using this formula, we identified the recharge. So during the first year, only with the pond, this was the recharge. During the next year, with the recharge shaft, the recharge has improved at least by 2.5 times. So this provided a kind of a successful case study. I'm not elaborating much more at this side, much more on this. So this has led to, searching for the slide, this has led to, suppose if this is the groundwater table is also very shallow because the mean sea level over here is very less. So the groundwater table was somewhere here, very saline. the water which has recharged, right? The head is like this, so it has formed a kind of a small lens below the surface, right? So this is a fresh water, this is saline water. Then we went ahead in providing a small hand pump, right? A hand pump which can take about, I don't remember the numbers, about 150 liters per day can be tapped using a hand pump, which will be sufficient for drinking purpose for small number of families which were living around that site. And the next is on, can we think of to overcome the problem of deterioration of groundwater quality, which we discussed, one of the climate change impact. So what is the sustainable way to overcome the problem? Right? Can we think of riverbank filtration for rural water supply? Right? Currently at many sites in southern India, right, in Krishna, Godavari, Kaveri, we have intake wells, right, which these wells are made in the river itself to tap water, river water for water supply. Since river water is very much contaminated, especially with the microbes, right? So can we think of riverbank filtration? So we identified a site where they came to us, right, the local municipality, since it is a pilgrimage area where surface water is very much contaminated, and surface water in the river also is available only for shorter span of time in a year, maybe for 1.5 to 2 months. Then we went ahead in constructing a check dam. Right, this is the flow direction of the river, right? And though this sea is here, the river flows this way. A check dam was constructed, as you can see here. This impounds large amount of water for nearly 5-6 months. But since the water is contaminated, especially with microbes, they need to do lot of disinfection, chlorination, which was not advised. So we did a study to understand whether we can go about in planning for a riverbank filtration well. Riverbank filtration well is a concept where we want to, rather than tapping river water directly, how about having a well little away from the river, so that we make use of the natural filtering process. It is a kind of natural treatment process, right? So for which we did a study over there, we found out the chemical quality of river water is good. So this is the river water. Chemically, river water quality is good, whereas groundwater is little bit saline. So you can see the distance from the river. These are all the wells. This is the river. And in river, since the river, which is where the check dam has been constructed, it will hold the reasonably clean water in terms of chemical. Whereas here on the right hand side, you can see the microbial colonies, right? That is colony forming units, which is much higher in the river. Whereas in groundwater, it will be obviously be less because of the slow transport and natural filtering process. So why not we, rather than tapping water from the river for water supply, why not we tap water from the wells? So that was the study. So we identified what can be the optimum distance. Generally, when the water travels nearly for 50 to 60 days through the sandy formation, the water will be devoid of microbes, right? Here the river water has got higher amount of microbe. That means electrical conductivity. Chemically it is good, but microbially it is poor. So as the same water migrates through the subsurface, it will get clean. So we identified if the production wells are located at this distance from the river, right, nearly 400 meters, right, these wells can tap groundwater, which will be considerably clean. Though we are tapping groundwater, the water which we are pumping, nearly 70 to 80% will come from the river. Okay. So this is another way to reach sustainability, to overcome the problem of deterioration of surface water quality. Then lastly, seawater intrusion. Right, Chennai city is very much affected by not the city, just north of the city. This is Chennai city, north of the city of Chennai, where the groundwater is very much affected. Right, you can see from 1969 to 2014. I am not doing any study now. right? This was the situation in 69. This was the situation in 2014. We did a DST supported project. So this is the concentration of sodium, concentration of chloride. This is the distance from the sea. This is the boundary sea here, and this is the land side. Distance from the sea, variation in concentration of sodium, variation in concentration of chloride. At the bottom, say spatial variation between 98 and 2014. 1988 is in black color, right? You can see the concentration of sodium was 200, whereas the red is 2500 in 2014. So much is the influence of seawater intrusion. That is because we were having some pumping station which was withdrawing large amount of groundwater to supply to the city. So what is the way forward? Again, several check dams. I think I skipped this. Right? This is one check dam which I already mentioned about the riverbank filtration. So we got a lot of information over a long-term study at this site for 4 years. That means since we suggested this location for the check dam, we commenced our study even before the construction of the check dam, and we continued our study for 3 years. Subsequently, after the completion of the check dam, we got a lot of information. Subsequently, right, there were suggestions for check dams at all these sites. Totally 15 check dams, all of them has been constructed now. Right, a year ago, the work was over. Since we did a study at this site, we extrapolated the same, right, empirically to other locations. After extrapolating this information, we carried out a regional surface as well as groundwater, integrated surface groundwater model, right, as a part of another major project. And these are all one slide I'm showing you the results, right? This is the situation in 2015. The model predicts by the end of this decade, since all these recharge steps, 15 check dams across these rivers have been constructed, the additional recharge will benefit the flushing of seawater intrusion toward the seaside. And also, I forgot to mention, we suggested a linking of these two rivers somewhere here. If I remember right, this work has not yet been taken up by the government. If you put this link channel, this will help in mitigating flooding as well as augment groundwater recharge. And lastly, how about making use of abandoned quarries? Right, everywhere in southern India, we have several quarries, right, which are not being completed as originally they planned, right? There was in several committees, though after extracting the rocks, they have to systematically close these quarries, right? But we seldom do that. Many a time nowadays they write as it will be converted as a recharge structure, right? So can we use them as a retention areas to hold some additional water, especially during extreme events? This is the city of Chennai. This is the Chennai airport. This is one of the largest reservoirs. There are 4 reservoirs that supply water to the city of Chennai. Adjacent to that, we found a big cluster of quarries, right? You can see this black color which you see here in Google image. They are about a cluster of quarries. In 2015, we had severe floods, but in 2019, we were severe drought. There was not much of water left out in quarries. Sometime during August, the monsoon failed. Then the Metro Water Authority, that is the water supply authorities, they met us for the quick remedy, right? They said, if you can suggest any location from 200 kilometers away from the city of Chennai, we will be able to fetch water, right? But then we identified, this used to always fascinate me. When you land in Chennai, you will see these quarries because the flight will land like this many times. So on your left-hand side, you will see these magnificent quarries. So how about converting these quarries as water holding ponds? So we did recently a PhD student completed her work. This is the reservoir. These are the quarries. Can we connect the reservoir to the quarries? That was the aim of this study. What will be the benefit we will get? So here are the benefit, right? Suppose if you connect the reservoir with the quarries, it is one of the resilient measure to overcome climate change. Suppose if the next year is going to be an excess rainfall here, what will be the benefit we will get? So the first red one is business as usual. So let us focus our attention to red and gray. Red gray is very feasible. So I don't want to explain everything, right? In gray, we are planning to divert about 150 cusecs of water from reservoir to the quarry. Suppose if you go in for this scenario, the water that is supplied to the city of Chennai can be improved from 60 to nearly 90, right? 90 million cubic meter per annum. Suppose if you are going to have a normal rainfall year, even then the water supply can be improved from 40 to 95. This is much more interesting. Deficit year rainfall, that means if the next year we are not going to have a normal rainfall, if we are going to have deficit rain, even then we are able to marginally improve the water supply. How this is possible? Because we are going to divert the water from the reservoir to the quarries, the evaporation loss will be considerably reduced. So this study we did very recently based on our research. Now the project has been sanctioned by the government. Now they are constructing a channel to link the reservoirs to the quarries. Even this is not enough for India. What next? That is what the government of India is now planning to do. That means how about using the used water? That means wastewater. Right? Can we think of using the used water for different purposes? Right? Here we did a study using a web-based model to understand the future scenarios and strategies for sustainable water management in Chennai Basin. As I told you, we considered excess rainfall, normal year rainfall, deficit year rainfall, and assumed, suppose if you go ahead and having treatment plants, right? That means something like water circularity. So can we use the treated water for some purpose? So if you assume from 2025 we are going to treat so much of water, this diagram, though it is a little bit cumbersome, what it shows is the model predicted unmet demand. So here you can see, right? Suppose if you go in for a water treatment plant from 2015 yearly for 10 years, there won't be any unmet demand. Right? Beyond which the unmet demand is increasing. That is because in this study we considered the increase in population in the city. So to commemorate with increase in population, we need to also periodically improve or increase the facility of water treatment. Right? So this is in way in IIT Madras. Right? We did while at Chennai University itself, we did a network project thanks to DST. Right, as a part of that, we carried out this study. So this is the treatment plant in Chennai where the water treated is due to ultrafiltration process. Water is drinkable. That is, domestic sewage is treated to a drinkable level. And what we are doing currently is the treated water from here, that is for 10 million liters of water, is let into a nearby water storage reservoir, nearby lake, which is located at a distance of about 5 kilometers. The pipeline has been laid, and the water is now discharged. Right, since last 3-4 years, the water is discharged into this lake. From another side of the lake, water is directly pumped and taken to water supply treatment plant, and the water is being supplied. That means we are actually completing the water circularity. I think this is what I wanted to share. And Chennai become the first city to recycle water at a large scale. And I will quickly run through. We are currently carrying out a study to rejuvenate groundwater resources in Bangalore with over 10,000 recharge wells are under construction. Already around 5,000 wells are completed. So this agency is carrying out a work, and we are the technical partners for that. I think I'll skip this. Right? You approximate calculation. Already about 6,000 completed. If you go in for 10,000 wells, if you just compare the capacity of the well, annually we'll be able to say at least so much of water which otherwise would have run on the surface. So this is another way to attain sustainability. So what we are facing today, right? As I was telling you, we are pumping large amount of groundwater. But are we going to continuously deplete groundwater resources? I don't think so. I think we have already reached the peak. Some of the recent data though I was searching, I could not get that, indicates on a positive side. I would like to complete, right, stating that though we are we have seen the peak. I don't think we are going to ever increasing the groundwater pumping with respect to time. I think we have reached the peak. Hereafter it is going to be a fall, which I think is a positive news, maybe due to all these schemes, right? We are also very serious. We have brought in several schemes, right? One additional scheme can be the ESGD, right? That is what NCESS is up to, right? If that comes through, can we use part of the water that is draining into the sea for augmenting our water supply? This will also enhance the sustainability. I like to conclude, right, more or less on the same lines. There was an interesting paper which also highlights that the groundwater withdrawal is going to decrease, right? So we have already reached we are somewhere here by 2050, they say the peak will be reaching, but in India, we have already reached the peak beyond which the groundwater withdrawal is going to decrease. What are all the reasons? Because it won't be no longer viable to pump water from deep, right? Maybe energy cost will be much more. Rather than that, we can use the wastewater for agricultural purpose or treated wastewater for different purposes. So if you look at the case of India or in our Indus basin, right, we have already reached the maximum, right? So as anticipated, right, there should be circularity everywhere. So we have reached the peak, and whole world by 2050, we no longer will be very much dependent on groundwater, which is the positive note. Though it is very positive, what is little bit negative, as I told you at the beginning, right? If you look at the regions in the northeast, especially in Himalayas, where the temperature rise is going to be much more than the rest of the India, due to which I gave a course for NPTEL on Himalayas, right? So that is why I collected this information, right? There are over 600 lakes in the Himalayan range. Out of that, more than about 90% of the lake's size has improved by 2 times, which is really alarming, right? So what is happening? The glacial lakes have melted, right? No longer they have ice. Here is one particular lake where you can see the data given by ISRO. It indicates the aerial extent of the lake has increased from 1989 to 2022, right? So in 1988, it was so small, the rest of the area was occupied by ice, but now it has expanded like this. So it is really pathetic. What is the way forward? We researchers have to work on this, right? Only way forward is to reduce the rate at which the atmospheric temperature is rising. The problem is much more severe for to save our glaciers. Whereas in the case of groundwater, almost we have reached a stage where we can boldly say the groundwater pumping, or we can at least say we have reached the level of sustainability. Whereas in the case of glaciers, it's a big question mark. With this, I would like to conclude. Aquifer recharge is the way forward, but not always. We have to be also very cautious. So sometimes the improved groundwater recharge, and though it improves the storage quality, is a big question mark. It will help in mitigation of floods and maintenance of these recharge structures. The government of India has promoted like anything. So everywhere we have groundwater recharge structures, but how are we going to maintain them? It is going to be a big challenge. Every year we need to do a kind of cleaning up. If we can do that, we'll be able to sustain the sustainability. And another cause of concern is the water that we use for recharge. That is also a concern, right? Even if it is of good quality, for example, as I told you, we are discharging ultra pure water into a lake, that will change the way in which geochemical reactions are taking place. So we are now, Government of India is working on coming out with their guidelines for this. With that, I would like to conclude my talk. Thank you very much for the opportunity. I'll be very, very happy to answer the questions. Thank you so much.
Thank you, Professor Elango, for that excellent talk on groundwater management. Now the session is open for discussion. So if you have any questions, you can pose it.
Professor Elango, am
Yes,
I audible?
please. Yes, very
Yeah,
much.
yeah. Very interesting talk as always. One thing is just struck me, why we are not resorting to this artificial rainfall in a big way. I mean, is there any problem or is it not feasible? I'm just curious.
Very pertinent question, right? Though many countries claim it is really successful, but I doubt the success rate of artificial rainfall is a big question mark. Right? For a country where we receive large amount of rainfall, the only issue I see is the way in which we manage or govern the water that falls. If you take the example of Chennai city receives 1.4 meters of water every year. Whereas if you take, you are there in many parts in Europe where the rainfall may be only 0.6 meters, 600 is the rainfall. They are able to manage, but here we are unable to manage. So I think the way in which the government approach this problem is correct, right? The only way is to augment whatever falls, right? The India now says catch the water where it falls is the way forward. But sometimes I also think crookedly, if everybody catches the water, what will happen to the sea, right? That is also a big question mark that we can work on that too, right? What will happen if everybody construct check dams and catch the water? So to answer you, right, the better option, since we have better option than artificially creating rainfall, I think we are on the right track. Maybe in countries where the rainfall is very, very less, for example, Gulf region, they can certainly go in for artificial. Thank you very much for your interesting question.
Good morning, sir. This is Prasenjit. I hope you can remember.
How are you? How are you?
Sir, I am doing well, sir.
Welcome.
So,
How is your
thank you
research
for
work
such
going on?
Yes, sir, it's going. So, thank you for sir for such an insightful talk. I have a couple of questions. One is why wastewater treatment and reuse is not that popular in India, especially when we can see that there are plenty of desalination plants, but proportionately we do not have that many wastewater management program going on, especially in bigger cities like metropolitan. And my second question is regarding the quarries that you referred for recharge, because the quarries are like dug in massive rocks, so it will have a very low secondary porosity. So how much it will be effective for artificial recharge?
Thank you very much for your comment and question. So to answer your first question, right, you are very correct. Though treating the wastewater is cost effective, right? It approximately, they say yesterday also there was a discussion here, right? It is going to be about 25 to 30 rupees per 1 meter cube, if I remember right? Whereas desalination is almost 1.5 to 2 times of the cost. Maybe because of the fact that there is a kind of psychological impact when we say that we are going to make use of the treated wastewater. That is one issue. And another issue is it is very easy for the implementers, for the governments to think of a desalination plant wherein they will get assured water, right? Whereas maintenance of wastewater treatment plant is much more cumbersome, but certainly it is cost effective. To overcome this issue, in the recently formulated national water policy, government is now pushing towards encouraging wastewater treatment. In 10 years from today, we will see a completely changed scenario. What you are saying will be in place. I'm sure already it is in place in small apartments, in big hotels. If you look into the big hotels in India, most of them, they use treated wastewater for toilet flushing. If you take IIT Madras, we completely reuse the wastewater, right? Either for toilet flushing, gardening, and the rest is left into a lake within the campus from the other side of the lake, they tap the water, treated and supplied. Right? So in down the years, certainly what you said will happen. The second question, quarries I mentioned not for recharge, just for retention. You are right, there cannot be any recharge from the quarries because they are all massive rocks. In spite of the fact they are fractured, the recharge may not be even 5%. Right? So they are simply used as a tanks or water storage facilities. Right? Since they are very deep. Thank you. Hope I am clear.
Hello, sir. Thank you, sir, for the insightful lecture. My name is Gino. I have a question on the concept of managed aquifer recharge. When we consider the topography of the Kerala, like we have mainly the three classifications, like highlands, midlands, and lowlands. And there are many approaches of managed aquifer recharge. So, with your expertise, like what do you suggest in each of these regions? Because if we consider the Kerala's topography, once the rainfall reaches, it will easily drain into the sea. And the recharge mechanism will be different in each of these three regions. So in highlands and midlands and lowlands, like what do you suggest, like which is the most effective way of managed aquifer recharge in order to optimize this recharge?
So yeah, perfect, right? In the case of highlands, what we can think of is small nulla bunds. Right? It should not be more than half a meter, right? We can impound water at the upstreams with the several small check bunds, right? Across the first order or second order streams, or wherever you have a relatively flat surface, similar to what I showed you, maybe like contour bunds. Okay. We have to be also very cautious to store water in the highlands because this will trigger landslips too, right? So it has to be on the carefully selected sites. We can go for small structures. In mid as well as lower level areas, we can plan for much larger structures, right? Maybe a check dams or spreading ponds, percolation ponds, recharge wells, all can be thought of for the low-lying areas. Right? So this is the way forward. But as you rightly said, in Kerala, the opportunities I feel is little bit lesser. Right? So we have to select site by considering not only to augment groundwater resources, but we should also see about the stability of the slope, which is also very, very important.
Okay, sir. Thank you. Thank you so much.
Thank you. Thank you.
Thank you, Professor Elango. Now we invite our director, Professor Rao, to give a closing remarks and also facilitate Professor Elango for kindly accepting our invitation.
Thank you very much, Professor Chalapati Rao and Srilash for giving me this opportunity, but I regret certainly for not being with you all today. Thank you so much, right? Especially because of the fact my close friend is the director now, right? The first, it would have been an excellent occasion for me. Yeah, Purnachandra, previously the Rao sir also I know, but not as close as I know you. Yeah. Thank you so much.
Professor Elango, despite your commitment there, you could spare your time and you could share your invaluable thoughts on the occasion, and we are very grateful for your presence. And I mean, I am sure everybody has thoroughly enjoyed. It just struck me, like in seismology, yes, we think of seismic microzonation. We need to look at microzonation for water resources also, because there is lot of diversity in lithology, climate condition, agrarian condition, so many. I was just thinking, we need to look in those terms, then it will be more effective than addressing the issue on a regional scale. I mean, it just struck me, people like you should...
No, absolutely.
Yeah.
Absolutely. In fact, over there I attended a meeting regarding our what is that, deep well drilling project. There was a meeting long time ago at ESSO-NCESS, if I remember right.
Right.
Over there also I suggested, but he said there is no water the deep wells, because if you can continuously monitor the water quality of these deep wells, there is a possibility of a link between what you said, microseismicity as well as dilation of rocks will have an impact on the groundwater quality too.
Right.
Yeah, these are all some future questions
And
which
also, and also I feel it should be recommended in NCRT, CBSE, ICSE, all syllabus from school level itself, at least one or two chapters should be dedicated to the groundwater resource, their conservation. Then it will be more effective, na? Instead of, I mean, we celebrate these days and very soon we forget. But if it is imbibed right from the childhood, I think it can make more difference. I'm not telling it is not there, but it should be incorporated more aggressively and taught also more systematically. I mean, these are some thoughts. Thank you so much again. And we have.
Thank you.
Yes, sir. Elango sir, can you stop sharing so that we can bring you in full screen?
Oh, sorry. Yes. Yes.
So, as a token of appreciation, that will facilitate you.
Wow. Super. Thank you. Thank you. So nice. Thank you so much.
Either many of us will be traveling to Chennai, either it would be brought there. I think myself would be coming again in April.
I am unable to hear you clearly. Okay.
Or any of my colleagues, I will hand it over to them. Or in other, I mean, if it's not possible, we'll courier it. In any case, this is for you. Okay?
Thank you. Thank you. Thank you. Thank you.
Thank you, sir. Thank you, Prof.
Thank you.
Yeah, thank you, Prof.
Thank you so much, Srilash. Thank you so much. It was a pleasure for me to be with you all. Thank you so much. Have a great day.
Thank
Bye,
you, sir.
bye.
And
Bye, bye.
thank you,
Bye, bye.
Director sir and colleagues for joining the talk. And we have high tea arranged for you in the corridor of the science club. Thank you. Thank you, sir.
For me, where you arranged.
We will courier it to you, sir.
Okay. Thank you.
Bye.
Thank you so much. Thank you.